Okay, I am Joy Thomas, and I'm presenting the Rising Waters 3D Worlds Cesium-OSM-Powered flood simulations. So, the objective of this project was to create a flood simulation game that allows users to explore communities under different flood scenarios. And why are we doing this? We're looking for ways to help youth mappers to explain the impacts of climate change and sea level rise on their communities, and just to see what does my world look like underwater. We're using OSM, Cesium, and the Unity engine. And so Unity is a video game engine that allows for users to create digital playgrounds and experiences. Cesium is a tool for Unity that allows users to visualize the visualize the globe by combining its terrain with satellite imagery, as well as the ability to overlay OSM buildings over the terrain. And a big part of this project is communicating the risk. Like climate risk is too abstract and distant for most people to grapple with. And seeing your hometown underwater tells a clear story about how you and your family might be impacted. And so I've got a demo to show. So here I am. This is Boston. I have the sea level just to be the current sea level, with no sea level rise. And I can adjust the height, in meters. And I have this link to the IPCC sea level projection tool. And so from here, we can go to the year 2150, uh, go for the SSP5 8.5 scenario for sea level rise. And because it's definitely going to be one of the more drastic examples, we can look at New Orleans, and New Orleans is projected to be hit with a 2.42 meter sea level change. And so in here now, we can just go to New Orleans. And it is 2.4 that it said on the sea level projection tool. So we set it to 2.4, and you can see that most of the city is underwater. And just for like, I guess like morbid fun examples, I hear that Cafe du Monde is really popular, so we can look up Cafe du Monde. And it brings us to Cafe du Monde, and it is clearly in an area underwater. Um, and the um, the future developments is to make a playable character that can traverse the environment by walking on the terrain, and then be able to traverse the sea by boat or jet ski, and get an aerial view by throwing up a drone into the air. I made this like jet ski and water physics and water simulation. The only thing is, it only works in a small scale environment. So I'm currently working on making it more expandable to work in bigger environments without performance cost. And yeah, big thanks to the Cesium ecosystem grant and the support from youth mappers. And that is all I got.
Thank you so much. That is really cool.